The 2011 earthquake off the Pacific coast of Tohoku was a magnitude 9.0 undersea megathrust earthquake off the coast of Japan that occurred at 14:46 JST on Friday, the 11th of March 2011, with the epicenter approximately 70 kilometers east of the Oshika Peninsula of Tohoku and the hypocenter at an underwater depth of approximately 30 kilometers. The earthquake is also often referred to in Japan as the Great East Japan Earthquake, and also known as the 2011 Tohoku earthquake, and the 3.11 earthquake. It was the most powerful earthquake ever recorded to have hit Japan, and the fourth most powerful earthquake in the world since modern record-keeping began in 1900. The earthquake triggered powerful tsunami waves that reached heights of up to 40.5 meters in Miyako in Tohoku's Iwata Prefecture, and which, in the Sendai area, traveled up to 10 kilometers inland. The earthquake moved Honshu 2.4 meters east, shifted the Earth on its axis by estimates of between 10 centimeters and 25 centimeters, and generated sound waves detected by the low-orbiting GeoCe satellite. On 10 March 2015, a Japanese National Police Agency report confirmed 15,893 deaths, 6,152 injured, and 2,572 people missing across 20 prefectures, as well as 228,863 people living away from their home in either temporary housing or due to permanent relocation. On the 10th of February 2014 agency report listed 127,290 buildings totally collapsed, with a further 272,788 buildings half collapsed, and another 747,989 buildings partially damaged. The earthquake and tsunami also caused extensive and severe structural damage in northeastern Japan, including heavy damage to roads and railways, as well as fires in many areas, and a dam collapse. Japanese Prime Minister Naoto Kan said, in the 65 years after the end of World War II, "This is the toughest and the most difficult crisis for Japan." Around 4.4 million households in northeastern Japan were left without electricity and 1.5 million without water. The tsunami caused nuclear accidents, primarily the Level 7 meltdowns at 3 reactors in the Fukushima Daiichi nuclear power plant complex, and the associated evacuation zones affecting hundreds of thousands of residents. Many electrical generators were taken down, and at least 3 nuclear reactors suffered explosions due to hydrogen gas that had built up within their outer containment buildings after cooling system failure resulting from the loss of electrical power. Residents within a 20 km radius of the Fukushima Daiichi nuclear power plant and a 10 km radius of the Fukushima Daini nuclear power plant were evacuated. Early estimates placed insured losses from the earthquake alone at $14.50 to $34.6 billion. The Bank of Japan offered 15 trillion yen to the banking system on 14 March in an effort to normalize market conditions. The World Bank's estimated economic cost was $235 billion, making it the costliest natural disaster in world history. Earthquake. The 9.0 magnitude undersea megathrust earthquake occurred on the 11th of March 2011 at 14:46 JST in the northwestern Pacific Ocean at a relatively shallow depth of 32 kilometers, with its epicenter approximately 72 kilometers east of the Oshika Peninsula of Tohoku, Japan, lasting approximately 6 minutes. The earthquake was initially reported as 7.9 MW by the USGS before it was quickly upgraded to 8.8 MW, then to 8.9 MW, and then finally to 9.0 MW. Sendai was the nearest major city to the earthquake, 130 kilometers from the epicenter. The earthquake occurred 373 kilometers from Tokyo. The main earthquake was preceded by a number of large foreshocks, with hundreds of aftershocks reported. One of the first major foreshocks was a 7.2 MW event on the 9th of March, approximately 40 kilometers from the epicenter of the 11th of March earthquake, with another 3 on the same day in excess of 6.0 MW. Following the main earthquake on the 11th of March, a 7.4 MW aftershock was reported at 15:08 JST, succeeded by a 7.9 MW at 15:15 JST and a 7.7 MW at 15:26 JST. Over 800 aftershocks of magnitude 4.5 MW or greater have occurred since the initial quake, including one on the 26th of October 2013 of magnitude 7.1 MW. Aftershocks follow Omori's law, which states that the rate of aftershocks declines with the reciprocal of the time since the main quake. The aftershocks will thus taper off in time, but could continue for years. 1 minute before the earthquake was felt in Tokyo, the earthquake early warning system, which includes more than 1,000 seismometers in Japan, sent out warnings of impending strong shaking to millions. It is believed that the early warning by the Japan Meteorological Agency saved many lives. The warning for the general public was delivered about 8 seconds after the first P wave was detected, or about 31 seconds after the earthquake occurred. However, the estimated intensities were smaller than the actual ones in some places in Kanto and Tohoku regions. This was thought to be because of smaller estimated earthquake magnitude, smaller estimated fault plane, shorter estimated fault length, not having considered the shape of the fault, etc. There were also cases where large differences between estimated intensities by the earthquake early warning system and the actual intensities occurred in the aftershocks and triggered earthquakes. Geology. This megathrust earthquake was a recurrence of the mechanism of the earlier 869 Sanriku earthquake, which has been estimated as having a magnitude of at least 8.4 MW, which also created a large tsunami that inundated the Sendai Plain. 3 tsunami deposits have been identified within the Holocene sequence of the plain, all formed within the last 3,000 years, suggesting an 800 to 1,100 year recurrence interval for large tsunami-genic earthquakes. In 2001, it was reckoned that there was a high likelihood of a large tsunami hitting the Sendai Plain as more than 1,100 years had then elapsed. This earthquake occurred where the Pacific Plate is subducting under the plate beneath northern Honshu, which plate is a matter of debate amongst scientists. The Pacific Plate, which moves at a rate of 8 to 9 centimeters per year, dips under Honshu's underlying plate, building large amounts of elastic energy. This motion pushes the upper plate down until the accumulated stress causes a seismic slip rupture event. The break caused the seafloor to rise by several meters. A quake of this magnitude usually has a rupture length of at least 500 kilometers and generally requires a relatively straight fault surface. Because the plate boundary and subduction zone in the area of the Honshu rupture is not very straight, it is unusual for the magnitude of its earthquake to exceed 8.5 MW. The magnitude of this earthquake was a surprise to some seismologists. The hypocentral region of this earthquake extended from offshore Iwata Prefecture to offshore Ibaraki Prefecture. The Japanese Meteorological Agency said that the earthquake may have ruptured the fault zone from Iwata to Ibaraki with a length of 500 kilometers and a width of 200 kilometers. Analysis showed that this earthquake consisted of a set of 3 events. Other major earthquakes with tsunamis struck the Sanriku coast region in 1896 and in 1933. The source area of this earthquake has a relatively high coupling coefficient surrounded by areas of relatively low coupling coefficients in the west, north, and south. From the averaged coupling coefficient of 0.5 - 0.8 in the source area and the seismic moment It was estimated that the slip deficit of this earthquake was accumulated over a period of 260 to 880 years, which is consistent with the recurrence interval of such great earthquakes estimated from the tsunami deposit data. The seismic moment of this earthquake accounts for about 93% of the estimated cumulative moment from 1926 to March 2011. Hence, earthquakes with magnitudes about 7 since 1926 in this area only had released part of the accumulated energy. In the area near the trench, the coupling coefficient is high, which could act as the source of the large tsunami. Most of the foreshocks are interplate earthquakes with thrust-type focal mechanisms. Both interplate and intraplate earthquakes appeared in the aftershocks offshore Sanriku coast with considerable proportions. The strong ground motion registered at the maximum of 7 on the Japan Meteorological Agency seismic intensity scale in Kurihara, Miyagi Prefecture. 3 other prefectures, Fukushima, Ibaraki and Tochigi, recorded an upper 6 on the JMA scale. Seismic stations in Iwata, Gunma, Saitama and Chiba Prefecture measured a lower 6, recording an upper 5 in Tokyo. In Russia, the main shock could be felt in Yuzhno-Sakhalinsk and Kurilsk. The aftershock at 6:25 UTC could be felt in Yuzhno-Kurilsk and Kurilsk. Energy. The surface energy of the seismic waves from the earthquake was calculated to be at 1.9 times 1017 joules, which is nearly double that of the 9.1 MW 2004 Indian Ocean earthquake and tsunami that killed 230,000 people. If harnessed, the seismic energy from this earthquake would power a city the size of Los Angeles for an entire year. The seismic moment, which represents a physical size for the event, was calculated by the USGS at 3.9 times 1022 joules. Slightly less than the 2004 Indian Ocean quake. Japan's National Research Institute for Earth Science and Disaster Prevention calculated a peak ground acceleration of 2.99 grams. The largest individual recording in Japan was 2.7 grams, in the Miyagi Prefecture, 75 kilometers from the epicenter. The highest reading in the Tokyo metropolitan area was 0.16 grams. Geophysical effects. Portions of northeastern Japan shifted by as much as 2.4 meters closer to North America, making some sections of Japan's landmass wider than before. Those areas of Japan closest to the epicenter experienced the largest shifts. A 400 km stretch of coastline dropped vertically by 0.6 meters, allowing the tsunami to travel farther and faster onto land. One early estimate suggested that the Pacific Plate may have moved westward by up to 20 meters, and another early estimate put the amount of slippage at as much as 40 meters. On the 6th of April, the Japanese Coast Guard said that the quake shifted the seabed near the epicenter 24 meters and elevated the seabed off the coast of Miyagi Prefecture by 3 meters. A report by the Japan Agency for Marine Earth Science and Technology, published in Science on the 2nd of December 2011, concluded that the seabed in the area between the epicenter and the Japan Trench moved 50 meters east-southeast and rose about 7 meters as a result of the quake. The report also stated that the quake had caused several major landslides on the seabed in the affected area. The Earth's axis shifted by estimates of between 10 centimeters and 25 centimeters. This deviation led to a number of small planetary changes, including the length of a day, the tilt of the Earth, and the Chandler wobble. The speed of the Earth's rotation increased, shortening the day by 1.8 microseconds due to the redistribution of Earth's mass. The axial shift was caused by the redistribution of mass on the Earth's surface, which changed the planet's moment of inertia. Because of conservation of angular momentum, such changes of inertia result in small changes to the Earth's rate of rotation. These are expected changes for an earthquake of this magnitude. The earthquake also generated sound waves detected by the GeoCE satellite, which thus serendipitously became the first seismograph in orbit. Soil liquefaction was evident in areas of reclaimed land around Tokyo, particularly in Urayasu, Chiba City, Funabashi, Narashino, and in the Koto, Edogawa, Minato, Chuo, and Ota wards of Tokyo. Approximately 30 homes or buildings were destroyed and 1,046 other buildings were damaged to varying degrees. Nearby Haneda Airport, built mostly on reclaimed land, was not damaged. Odaiba also experienced liquefaction, but damage was minimal. Shinmoadaki, a volcano in Kyushu, erupted 3 days after the earthquake. The volcano had previously erupted in January 2011. It is not known if the later eruption was linked to the earthquake. In Antarctica, the seismic waves from the earthquake were reported to have caused the Whillans ice stream to slip by about 0.5 meters. The first sign international researchers had that the earthquake caused such a dramatic change in the Earth's rotation came from the United States Geological Survey, which monitors global positioning satellite stations across the world. The survey team had several GPS monitors located near the scene of the earthquake. The GPS station located nearest the epicenter moved almost 4 meters. This motivated government researchers to look into other ways the earthquake may have had large-scale effects on the planet. Scientists at NASA's Jet Propulsion Laboratory did some calculations and determined that the Earth's rotation was changed by the earthquake to the point where the days are now 1.8 microseconds shorter. Aftershocks. Japan has experienced over 1,000 aftershocks since the earthquake, with 80 registering over magnitude 6.0 MW and several of which have been over magnitude 7.0 MW. A magnitude 7.4 MW at 1508, 7.9 MW at 1515 and a 7.7 MW quake at 1526 all occurred on the 11th of March. A month later, a major aftershock struck offshore on the 7th of April with a magnitude of 7.1 MW. Its epicenter was underwater, 66 kilometers off the coast of Sendai. The Japan Meteorological Agency assigned a magnitude of 7.4 MJMA, while the U.S. Geological Survey lowered it to 7.1 MW. At least 4 people were killed, and electricity was cut off across much of northern Japan, including the loss of external power to Higashi Dori nuclear power plant and Rokusho reprocessing plant. 4 days later, on the 11th of April, another magnitude 7.1 MW aftershock struck Fukushima, causing additional damage and killing a total of 3 people. On the 7th of December 2012, a large aftershock of magnitude 7.3 MW caused a minor tsunami. And again on the 26th of October 2013, small tsunami waves were recorded after a 7.1 MW aftershock. As of the 16th of March 2012, aftershocks continued, totaling 1887 events over magnitude 4.0, a regularly updated map showing all shocks of magnitude 4.5 and above near or off the east coast of Honshu in the last 7 days showed over 20 events. As of the 6th of December 2013, there have been a total of 776 aftershocks of 5.0 MW or greater, 112 of 6.0 MW or greater, and 8 over 7.0 MW as reported by the Japanese Meteorological Agency. The number of aftershocks was associated with decreased health across Japan.